Hello and thank you for watching my video. My name is Brian and in this exercise we will configure CoPP, aka Control Plane Policing. Topics covered will be Control Plane Policing and its uses, configuring an ACL, class map, policy map and finally a service policy to complete CoPP configuration. Once we configure CoPP, we will do some testing and validate that it is functioning correctly. For ease of demonstration, I will be using Cisco's modeling labs. You can purchase at cisco.com or sign up for some free lab time at developer.cisco.com under DevNet Resources, Sandbox, Networking. It really is a great alternative to building a home network. Control Plane Policing, CoPP, is a security mechanism used to restrict the rate of traffic that is directed towards the control plane of a network device. The control plane is responsible for managing and maintaining the routing and forwarding tables that enable network communication, and it is essential to the proper functioning of the network. CoPP is used to prevent attacks that may target the control plane by limiting the rate of traffic that is allowed to enter the control plane. By doing so, it ensures that the control plane is not overwhelmed by traffic, which could cause a denial of service or distributed denial of service attack. Control Plane Policing uses. CoPP may be used in several instances in a network, such as protecting network infrastructure. By limiting the rate of traffic that is allowed to enter the control plane, it can prevent attacks, ensuring the network remains secure and operational. Prioritizing traffic. CoPP can also be used to prioritize traffic that is directed towards the control plane. By allowing certain types of traffic to pass through at a higher rate, it ensures that critical network traffic, such as routing protocol messages, are not dropped or delayed. Mitigating network congestion. CoPP can be used to mitigate network congestion by limiting the rate of traffic that is directed towards the control plane during periods of high network utilization. By doing so, it ensures that the control plane remains responsive and does not become a bottleneck in the network. Overall, control plane policing is a critical security mechanism that helps ensure the stability and reliability of a network by protecting the control plane from malicious traffic. In this exercise we will use two routers connected to a switch using the native VLAN. On router A I will configure the CoPP parameters, then we will run some ping testing from router B. Let's configure the host name and IP addressed on the routers. Enable. Config term. Hostname router A. No IP domain lookup. For this exercise I'll use the 172.16.1 network with a 24-bit subnet mask. Let's use the show IP interface brief command to verify the interface is up and has the correct IP address. Now router B. I'll save the configuration with the right mem command. Let's verify connectivity by pinging router A. Success. Now let's configure a policing policy that will help prevent distributed denial of service attacks that utilize ping. Let's start on router A, and create an extended access list called icmp.acl. It will match any ICMP traffic coming from router B. To create the access list the command is IP access list extended and the name icmp.acl. Then permit ICMP, the IP of router B, followed by a wildcard mask of all zeros indicating a single host with destination of any. Next, we need a class map. I'll name it sys.icmp.class. The class map command will be used to create a traffic class by having it match the ACL with the traffic type we have created. The command to create the class map is class map and its name sys.icmp class. Then the command match access group name, which is the ACL name we created, icmp.acl. Now that we have created the class map, we need to create a policy map that polices the traffic from our class map. And we want to drop ICMP packets above the bit rate of 8000. The command is policy map and its name. I'm calling this one input.policy. Next command is class. Here you see the options. We will use the name of our class map. Then the police command. Here are its options. I am going to set it to 8,000. Next, we want to use the conform action option, transmit, and exceed action. And we want the action to be drop. Now the traffic policing will manage the rate of the ICMP traffic. The command, police, 8,000, conform action, transmit, exceed action, drop, sets the policy to limit the ICMP traffic to 8,000 bps or bits per second. Any ICMP traffic under 8K is considered or classified as conforming. Traffic over the 8K bits per second limit is determined to be exceeding, and because we have drop specified in the policy, the traffic will be dropped and not processed by the CPU, thus helping prevent a resource overload that occurs during denial of service attacks. And the last part to configuring CoPP in this exercise is we need to create a service policy that will apply the policy map we created in the inbound direction. Config T. Control plane. Service policy. Input. And the policy name. Input.policy. And that's it. Let's do some testing from router B. From the ping output here, we can see half of the packets are not returning replies. Let's go back to router A and confirm we have dropped ICMP packets. To check the service policy, we need to run the command show, policy map, control plane. Here we can see that indeed there were dropped packets. Let's recap. 1. We discussed what control plane policing is and its uses. 2. We configured an ACL for ICMP traffic. 3. We configured a class map and had it match the conditions in our ACL. 4. We configured a policy map to take the class map we created and police it. 5. We configured a service policy under control plane and told it to use the policy map we created inbound. 6. We tested our CoPP configuration by using extended ping, and we verified that ICMP packets were dropped. 7. And always, document. Thanks again for watching this video. Please give a like and subscribe so you will be notified when more videos are uploaded.